Good afternoon, everybody. Welcome to the next in our series of CCFG webinars. I'm Bill Mason. I'm the chair of the Continuous Cover Forestry Group, and I'm speaking to you from our basement room in Edinburgh, which gets filled up with rather a lot of clutter, as you can see in the background. Pleasure to introduce Andy, who I've known for over nearly 30 years, I think. Ever since I joined the Continuous Cover Forestry Group. Andy's one of the founder members of the Continuous Cover Forestry Group.
As a couch potato. What? Why? And then 2 years ago, I decided that to avoid an early grave.
Andy acts as a manager and consultant for a number of large private estates in the southwest of England, as well as a number of other public and commercial clients. He's considerable experience in continuous cover, particularly in managing sites which have high nature conservation and heritage values. He's got expertise in broadleaf silviculture and forest economics and mensuration. Andy, delighted to welcome you and for you to give your presentation on continuous cover in lowland woodlands.
Thank you, Bill. Well, good afternoon, ladies and gentlemen. Let me go to see if this technology works. Okay. So yeah, my name's Andy Poore. I operate mostly in South. Sorry, wait a minute. Let's go to. Right, there we are. Okay. So I operate mostly in Dorset and Wiltshire. It's not quite like that anymore. That's a painting from or drawing from the 16th century. The raw forests have mostly gone, and there's not many naiads in the streams anymore. But I do operate a bit further afield in the Cotswolds, Surrey, Hertfordshire, and also one of my estates I've built up quite a significant portfolio of upland Sitka in mid Wales. So I manage I work mostly on big private estates, the sort of 1,000 to 2,500 acre areas of forest, plus quite a large area, about 2,500 acres of parkland, wooded heath, wood pasture, that sort of thing. Broadly 50% broadleaf, 50% conifer, leaving the Welsh woods to one side. Lots of ancient woodland and some large blocks of ancient semi-natural. I'm lucky virtually all the stands I operate in are on sites where you can grow reasonable to a very good quality broadleaves. So the soils are mostly brown earth over chalk, fertile sands, glaze, and heavy clay. And glaze over heavy clay. So over the last 25 years, well, probably 30 years, but certainly the last 25 years, my forests have moved more and more towards using CCF principles, and it's the default setting now across about 8,000 acres of managed estate. And those, oops, sorry. Right, yeah. And so, yeah, so now the default setting on most of these estates is a form of CCF. This is a large subject I'm trying to deal with today. It's a relatively short presentation. So what I'm going to do is give you some ideas. We're going to have to go through some key ideas and principles of the form of CCF that I and my colleagues use. It's a practice that's developed over the last 25 years with the help of my colleagues in Select 4 and a number of very experienced European foresters, particularly from Germany and France. Select 4 is a group of 4 practitioners who came together to be able to offer consultancy services in continuous cover, and that's expanded into quite an extensive training and research program as well. We all have our individual management companies, but we come together to do things together with regard to CCF. Now, I'm going to give you the edited highlights of a course which David Pengelly and I run. It takes 2 days with field trips and marking exercises. So this is a bit of a quick flight through some of these. This what is a very significantly large subject. I'm not going to talk much about the detail of economics. I'm not talking about monitoring or data collection. Both of those aspects feature quite highly in the course. But what I am going to talk about is try and concentrate on a number of these issues. So, and the issues that have dominated what I've been trying to do over the last 25 years. So the first thing is thinking about managing existing stand variability. Secondly, this idea of focusing on filling your stand with key elements which have good growth and good vitality. We're meant to be talking largely about broadleaves, so I'm going to talk specifically about how broadleaves differ from conifers. And it's worth saying at the outset that the practice in conifers is much longer and more well established than it is in broadleaves. And then the last thing, this particular issue, which I have been faced with a lot on large estates with large SSIs, this whole question of how we can create complex wildlife habitats in a way which is economically sustainable. So just before we get into that, so what are the drive? Why have I done this? Why have I suddenly moved? Why over the last 25 years have I moved from what might be regarded as a more conventional approach to management to something which is really now dominated by CCF principles? Well, the first thing is actually primarily economic. In the lowlands with relatively small woodland estates, we've got to try to achieve an economic performance which is based on better timber assortments, lower risk and lower costs. So it's not been predominantly driven by environmental factors. However, because most of my estates have got significant biodiversity and landscape values, the question is, how do you actually keep timber production going when you're trying to also produce these other results? And I'm absolutely certain that on all of these estates, I've produced more timber over the last 25 years by using a more selective, irregular approach than I would have been able to do had I been relying on cliff felling. There's other aspects towards landscape. The whole shooting issue is important. And with regard to nature conservation, the alternatives, which are broadly plantation forestry and coppicing largely, both of those I've found to be very difficult to achieve in any sensible fashion. So what I've been trying to do is find a way of achieving a dynamic high forest system which delivers high levels of structural and species diversity and better resilience at lower risk. And if you'd asked me these questions of why I did it in the early 1990s, I would have talked about the 1990 storm, which was very significant in southwest England, and I would have talked about the fact that all my even age stands had holes knocked in them, and how I had to come up with a system which accepted those effects, but where the system was not overwhelmed by it. Now, come forward 25 years, and of course, in addition to windblow, we've had periods of drought, and more recently, we've had this whole series of pests and diseases, and the whole issue of resilience has now become a very major one. So the idea, again, is to try and, I've spent 15 years effectively trying to create structures which are more resilient. So, but the other key thing about why I ended up not doing the conventional thing is to do with this, because in the lowlands, there are actually relatively few stands that actually conform to the even age model of a pure species with relatively all the same age, covering the whole of the compartment. In fact, it's the rare exception. And most of my stands, whether they were plantations from after the Second World War or before the 19th century or early 20th century, or if they were semi-natural, I had diversity in terms of species. Stocking varies a lot. Even in plantations established in the 70s in the lowlands, there are areas of understocking and no stocking sometimes. Quality is very variable. And the spatial distribution of these better elements is nearly always not on a regular grid. The regular grid that you're taught to create when you're trying to optimize an even age stand. And another thing to think about is that this variability that I'm talking about is actually increasing. It's increasing externally because we're being told to plant more species. And the whole idea of increasing species or diversifying species composition has in many ways been talked about a lot first, rather than what is perceived the more complex idea of having structural diversity. And of course, the more disturbances we have from these range of biotic threats and climate change, the more variable the species, the stocking, the quality is going to be. So this really, again, was a major driver. How do we optimize the economic performance of these stands with existing stand variability? Because trying to use the conventional approach was very problematic. Now, I'm afraid we have got to just talk a bit about definitions and what I do. What we're talking about is trying to, in general, we are trying to develop stands which are permanently irregular. So it's all the sizes on the same place. It's trying to create an intact forest ecosystem and manipulate it. Selective harvesting is really the key thing. Regeneration is sporadic and it's not timed to coincide with regeneration events. We're managing the whole stand, not gaps. Now that whole system started off in Switzerland and nearby France and Germany, and it was associated primarily with these native species of silver fir, Norway spruce, and beech, and with key people like Henri Biolay in the late 19th century. Now, it is highly developed in these particular stand types, and these stand types have relatively shade-tolerant species within them and relatively high stocking. But in the last 30 years, the approach has been adapted and developed for the use of stands dominated by more light-demanding species, particularly oak, ash, and then Douglas fir, and now pine. It's come largely from a different part of the continent. It really developed first in eastern France and has now become embedded in what might be called silviculture, but it's actually more of an emphasis of its use in private and communal forests on the continent rather than the state forests of Central Europe. And this development of trying to come up with a system, and I've called it a new fashioned selection system. It's more flexible than the classical one. There's more of a focus actually on timber quality and economic optimization at stand level. And it's particularly associated with a group of French forest managers in eastern France who formed an association called the AFI, and I'll talk to you about them a bit more later. And these are this is where our practice comes from. So it comes from originally from people in Central Europe. It comes from CCFG and particularly the European umbrella organization, which we're part of, ProSilva Europe. And 30 years ago, when we had very little practical experience ourselves, they were a major source of support and allowing us, as our practice developed, to us to be able to calibrate against theirs and to gain some confidence. And as you say, this particularly in 2005, we made a contact with the AFI, who are this group of private forest managers, and the guy on the left, up in the top left-hand corner, is a guy called Max Bruchia-Machi, who's a Corsican, and he's a forest scientist of great vision and skill. And that lot have enabled us to make significant progress, and particularly with regard to broadleaves, because the big controversy in Europe was, well, the selection system's okay, but you can't really use it for oak and ash. Now, there are other approaches included in what we call CCF. I tend to call all this irregular silviculture because that's the thing, because we're aiming for permanently irregular structures. Now, shelter woods exist. It's different. It involves creating more sizable gaps, the fellings linked to regeneration events. Now, I don't use that very much in the lowlands. I certainly do not use it as the default setting, because this over opening causes the loss of control of the seedbed. Basically, get too many weeds. That gives you a very short regeneration window. So this idea of felling and then at the same time as the seed is available doesn't work. Or if you're looking at broadleaves, the broadleaf stands are very often fragmented. It's almost impossible to coordinate large amounts of felling with a good seed year. When you do succeed, you're often too successful and you end up with too much regeneration, and then you're into tending cost. And the last bit, which is important, is that any creation of gaps will involve some degree of non-selective tree removal. And selection is the center of what we're trying to do. So in my view, generally higher risk, shelter woods are higher risk, and they produce poorer economic results. However, although we're generally treating these stands as a whole, there are situations where we need to do some group working. And that's sometimes in a semi-permanent way. So on very steep slopes, we can't use our normal techniques. And with light demanding species, we do push the structure a bit so that the light is concentrated in slightly bigger areas. But at no time are our gaps more than about 0.1, because they're being created in structures which have got relatively low growing stocks in the first place. On a more permanent basis, we get involved with groups where we've got the wrong species, where we're looking at pause restoration and want to change species because of that, where we have concentrations of mature stems, and obviously where there are unstocked areas. And now, as we're getting more stand collapse to do with ash dieback and windblow and things like this, clearly that produces by default some group working. So let's have a quick look at some key ideas. So this is one of the most important ones. Forget about after thin spacing. And it's worth saying that these principles are the same for broadleaves and conifers. There's no fundamental difference between the two. So the same principles apply. So forget about after thin spacing. That is the most important thing. It allows you to work with your existing variability and really go for the trees that are doing the most good in the stand, whether for timber production or nature conservation. Now, God didn't put the best elements of the stand in an even grid. So if you follow the best elements in a stand, you naturally produce irregular spatial distributions. The second big idea, we try and maintain the better trees in the stand, not all the trees, but the best elements. We try and maintain them to their optimal size before we fell them. So they're not even considered for thinning or felling until they reach that point. And we're also trying to maximize the performance of the stand on the basis of these individual trees, not every individual tree, but the individual good trees. We're not trying to optimize the economic performance at the whole compartment scale as you would with an even age stand. Now we can define the optimal felling size. I'm not going to go into it, but you can, we do, and we use these sizes in our marking. Another key idea, we want to grow more big trees and fewer small trees. And that's to do with better markets. And most species now, you'll get better value for the bigger tree when you're in reasonable quality, and also lower harvesting costs. Now that's quite a sophisticated, the whole question of harvesting costs is quite sophisticated, and we could spend quite a long time over that, but it is an important aspect. Now we've seen that diameter growth and price size curves, well, these are the main drivers. If you know how fast your best trees are growing and you know what your price size curve is, you can optimize your economic performance. The price size curve is the price per cubic meter of trees as they become bigger. Now, one other very key point to bear in mind is that the big trees or bigger trees grow at in a different profile in an irregular stand than in an even age stand. This is from Swiss data, and it shows that the red is an even age stand, and it shows diameter increment peaking quite early and then declining very quickly as the stand closes up. It's the opposite with regard to fully irregular stands. And the key thing is that big trees isolated in the top of the structure, which is what we're trying to get to, keep on growing at a fast rate. And that's a very important economic thing to bear in mind. Just to show that it works in The UK, there's data from Wiltshire showing exactly the same thing with Douglas fir, spruce and hemlock. We need the appropriate light levels at all parts of the stand. It's not just the seeding regeneration, it's the recruitment of the trees in the middle of the structure. And with broadleaves, it's particularly important for understory development. There's an emphasis on natural regeneration, and we want it to be sporadic, and we want it to be not everywhere. We want it to be pretty continuous. That's got major benefits for genetic improvement. But quite often, particularly in the transition, we have to use enrichment planting as well. So this happens in this case where we're trying to diversify spruce stands with Douglas and Thuya. And in this case, which is happening more now, where we can't anymore rely on ash as a reliable way of restocking stands, which we have in the past. And this use of enrichment planting to make sure that we've got one particular stand element, in this case oak. So this is more common in broadleaves than in conifers. The whole thing about risk management and resilience is obviously key. The whole thing about this system is that small scale disturbances are part of it, and they're integral. And you can have small scale disturbance without it interfering with your system, particularly. If you get major disturbances in a developed stand, there are some younger stand elements to take over. There's an economic aspect to it, which we not got time to go into now, but there have been general terms. High resilience of irregular stands is to do with their higher stability, a higher proportion of vigorous big trees, this genetic adaptation that we're creating, and the avoidance of adverse conditions. And the things to avoid, and this is often in broadleaves, are these sorts of things. Dense pole stage stands are associated with drought in beech, for example, on limestone. Many of these dense stands have high humidity, which when you've got fungal problems like red band needle blight or ash dieback, you get much higher degrees of spore production. Stands of intolerant species like oak and ash, they really tend to have very poor vigor and vitality when these stands are closed. A lot of these trees are stressed. We must try and avoid that. Any trees with poor crowns and low vigor are likely to be less resilient. Now, there is a direct link between structure and resilience. And when you then add in the issue of genetic variability and tolerance to disease, we come to a PhD that I've been running at Rushmore for the last 5 years, which is looking at this relationship in ash dieback. I don't propose to go into it now, but if someone wants to ask a question at the end, I'll talk about that a bit more. But the point is that structure can make your forest more resilient. So in terms of stand structures, what we need to find a structure where all these ideas apply. Now, accommodating different species requires different types of structures. It's not about the size of the gap. So that's an important thing to think about. And when we're talking about an ideal growing stock, where we're eventually trying to get to some sort of equilibrium, there's two aspects to it. There's the correct total amount of trees on the site, and then there's how the distribution of those trees runs across the sizes. We're obviously always in the long run hoping that we can increase increment by improving the stand in terms of its vigor and its ability to resist disease. So this is where we are in conifers. So if you don't understand basal area, which is a stocking parameter, don't worry too much about it. Just look at the numbers. Just get a sense on the left-hand side what sort of number we're talking about. And you can see that the more shade tolerant species like the spruces, Douglas and Western red cedar have significantly higher target stocking than the more light demanding ones. We can talk about the way in which that across the sizes, we could spend a long time talking about this. Quite often it's described in terms of a stem frequency distribution. We tend to use the chart on the right, or that formulation. We block the diameters up into larger groups and we assign basal area to those. The key thing to remember is that the distribution between the sizes varies an awful lot depending on the maximum size of the tree that you're including in your production system. That's another important thing to bear in mind. With conifers in transition from even age to irregular, we have this sort of 3-stage process, which we've defined, which is quite well adapted now. We've used this a lot. It's relatively easy to interpret, and it's fairly straightforward. But when we get to broadleaves, so how are these different? I mean, regarding those broad principles, how is it different? Well, the first thing that's different is that these ideal growing stocks are significantly lower. So if you just go back to, that one, you can see that number, how they vary. So we're looking at significantly lower growing stocks that we're aiming for in the long run. Now, why is that? Well, it's to do with the fundamental stand morphology of broadleaves. And there are 2 major aspects to it. The first thing is that the actual overall stand height is often much higher in developed irregular stands. So if you go to Cuvée in Switzerland or Stourhead Western, the big silver fir or Douglas fir are 55 meters tall, the big trees, the few of them stuck up in the top of the structure. Broadleaf stands rarely get above 35. So you've got a lower box you're playing with. Now that means, in principle, the higher the box, and with the same amount of stocking, the more light there is at the bottom of the stand with a higher box. Now, when you combine that with another major difference, this is the amount of crown cover required to produce a given amount of diameter growth. So what it means is that, and in this diagram, you've got diameter along the bottom. Up the left-hand side is a measure of how much crown area is required to produce a given amount of diameter increment. And all the ones at the top are broadleaves, and all the ones at the bottom are conifers. So first of all, the ones at the top mean that you have to have more cover to produce a given amount of growth. And it's notable also that with what we might call shade tolerant species, beech, sycamore, for example, the younger ones are even less efficient in terms of the amount of cover you require. Now you put those 2 things together, and that fundamentally explains why you need lower growing stocks in broadleaves than you do in conifers. Now, one of the major results of these lower growing stocks, i.e. more open stand conditions, is that it's very easy to lose control of the seedbed. And the whole issue of having an understory is very important. Now, natural regeneration, you can have an understory, as is developing the left-hand photograph, which is where you've got ash coming up through bramble. But very often, you have a scenario like in the right-hand side, where the areas of the stand that are a bit more open can get dominated by, in this case, Carex in West Dorset. But you can see how important the hazel understory is in this case. So you've got a summer picture at the top and a winter at the bottom. Underneath the hazel, there are effectively potential regeneration niches. So silviculture and understory, and it can be hazel, it can be birch. Birch works very well as well. But it's absolutely critical. And it also turns out that an integrated shrub layer is a real driver of biodiversity. Just a quick one to say, this is one reason why the whole AFI was set up, in order to demonstrate the relationship between things like growing stock size and regeneration. This shows that there's plenty of evidence in the stands across the AFI network that you can get very good regeneration of these species within permanently irregular stands. Another key thing about broadleaves is that in terms of regenerating the main stand, i.e. taking small trees and putting them in the main stand up in the top of the structure, you're relying on a relatively few number of trees, but they're absolutely critical, and they're actually quite difficult to achieve. So we spend more time making sure that we have a few really good poles and that they're not knocked over during the harvesting operations. It's important for the continuity of the stand that a few, but there must be some high quality individual poles are available. In terms of transition, it seems a rather more, it's a more simple framework. You start off trying to get the stand into the right growing stock size, and then you try and manipulate the distribution between sizes. But in practice, stage 1 can be represented by a lot of different scenarios, and I've been through a lot myself, and it's more tricky and it takes a long time, and very often it does involve more enrichment planting. So finally, where I got to, almost 5 minutes. I just want to talk a bit more about this whole question of delivering biodiversity. This was particularly important for me really from the beginning of my practice back 30 years ago, because I happened to become the manager of some very large SSIs, which were large areas of ancient semi-natural woodland. And we had an ongoing debate with Natural England about the way in which we should be managing these. They were very much, it's got to be coppicing and ride management and nothing else would do. And I did a lot of that, but from the financial point of view, it's highly risky, very dependent on grants. And as I began to play around with the stands outside the coppice working circle and began to develop these irregular broadleaf stands with an integrated understory, I started to begin to realize we were getting somewhere with regard to habitat complexity. But there was no data. There was no data on how biodiversity output varies with different high forest structures. And so initially, I tried to conceptually think about what were the potential habitat attributes of an irregular high forest. And this is what I came up with. So this is what I thought in principle were the things that were likely to be beneficial. I'll just pick one of those as being something you might not think of, this habitat complexity in the varied leaf morphology. When we set up this research project I'm about to talk to you about, an lepidopterist did some scoping work with regard to the sampling we were going to do, and we looked at 2 stands of hazel, one on one side of a ride, which was simple coppice, no trees, and on the other side was part of an irregular structure, so it had dappled shade above it. And he found that he was looking at the distribution of leaf miners. These are the larvae of moths. And he found that not only was the number of species, but the number of individuals was much higher in the hazel underneath in the irregular forest compared to the simple coppice. And this was purely to do with the fact that the leaf morphology was much more complicated with the dappled light than where you had a scenario where light was you had complete overhead light. So initially, these were the principles I thought we were following. Now, at the level of an estate, the question is, how do we balance profit or cost effectiveness with biodiversity delivery? So I surmised that we could think about the 3 broad approaches that I had, which was coppice or scrub management in wide rides, limited intervention on the other hand, and this irregular high forest that I was trying to develop. In principle, you could characterize them by saying, well, coppice was very dynamic. It didn't have much in the way of old growth features. There's no lichen interest, for example, in any of the coppice stands at Rushmore, this estate I'm going to talk to you about in a minute. On the other hand, limited intervention, lots of old growth features, low ecological dynamism. The one in the middle I thought might be the best of both worlds. Now, from the economic point of view, the problem is limited intervention, you get no money at all. And coppice is very dodgy financially, very dependent on grant, very, very difficult to make any money out of. So the question was, in my mind, how much do we need of those 2? Now, Natural England said, well, we quite like this irregular high forest thing. We're quite happy for you to use it to deliver favorable condition, because this was after 20 years of me arguing about it. But this, of course, we've got no data. So this is where this came in. So 5 years ago, we set up this research project, which was looking specifically at the fundamental relationship between structural variables and direct biodiversity output. And we used birds, moths, and bats as the vector. So we're looking at the fundamental elements, what percentage of overstory, what percentage of understory, what's the total stand stocking. And then also, we had a subset of, so that covered 300 sample points. 120 of those were concentrated on stands which were clearly either simple coppice, and then we got a picture above. We still have coppice there with no trees, which is what you need to have any sort of sense of economic viability. So simple coppice was compared with irregular forest and limited intervention. Now, the stage of the project we had, we finished all the data collection about 2 years ago. The data has now been processed, and we've had 2 peer-reviewed papers on the basic results. There's a third and fourth of those going to be written, and then there'll be a congruence paper which will try and describe the variation between those will explain the results in terms of the structural variables that we've also measured. So in terms of birds, and I will say that these articles I'm showing you now are available on the Select4 website. I'll give you the website address at the end. These are really important papers. They're worth reading.
Andy, sorry to interrupt, but could you begin to wrap up?
Yep, I'm almost there. So just very quickly, the key things about this is that, first of all, there was a lot of variability in the bird. We're talking now just about the results and comparing them between these different ways of managing the forest. So there was a lot of variation. Spring bird densities were higher in the irregular forest for half of the species. The warblers were particularly interesting. These are ones that are very often, I'm often told, they're just in coppice. Well, they weren't. They were often highest in coppice, but they had the second highest and good populations in irregular. There were more in the irregular of these 6 of the 10 woodland specialists. And with regard to marsh tit, the irregular stands had some of the highest densities of marsh tit that have been found by the ornithologists anywhere. Excuse me. Here's the basic data, and just to show you, for example, that something like garden warbler, which is again meant to be a coppice specialist, there are none in the non-intervention here, but there are good populations in irregular high forest. We don't actually have to show that irregular high forest is better than anything else. We just need to show that it's more or less as good. When we come on to bats, we have the same sort of basic result, although bats are more complicated because they use the structure in different ways. There's another paper already published. Again, the same sort of result. In general terms, irregular, more activity, more richness. And if you look at the individual species, you can see this only actually soprano pipistrelle, which has a significantly more bats in unmanaged or low intervention than irregular. And even then, irregular has significant amounts. Now, this is a major result, because if you look on the website of many, in terms of guidance in this area, very often all these bat species are regarded as being managed best by non-intervention, and these results seem to suggest this is not true. And if you look at barberstrel, which in many ways is the marsh tit of the bat world, again, very significant densities within the irregular. So I think we're getting to the point where we do need some coppice, we need some permanent open space management, we need some limited intervention. But I think if we have the bulk of the forest in irregular high forest, we're going to be delivering a lot of biodiversity in a cost effective. And as I say, generally we make a profit. Okay, so that's the end. I'll just do a little plug for my training course. This has been a very swift whiz through. If you think you'd be interested in a bit more, then by all means go to the website. And you can also find a range of articles, including the ones we've just talked about. And a couple of publications. The one on the left, translated into English by Phil Morgan, is the one written by the AFI foresters. It also includes a lot of information about the research network, which we are part of. And the one on the right is a very interesting one written by a lady from the Wallonian Forest Service in Belgium. And what's really encouraging about hers is that it's fairly recent, is her language is exactly the same as ours. So we seem to have managed to then end up with a practice which is consistent throughout, certainly into Belgium, southern Germany and France. Okay, thank you very much.
Thanks very much, Andy. Michelle will probably side by side gallery. Quite a few questions.
Sorry, do you want me to should I stop sharing? That'd be a good idea.
Please, if you don't mind.
Yeah, okay.
That's
yeah.
great. I've got quite a few questions, and if people can bear with it, I'll try and take the ones that seem to link together. First one relates to the, what did you call it? The integrated shrub layer?
Yep.
And the hazel. Could you say a little bit about whether you need to manage this, and can the hazel inhibit regeneration in the same way as the overstory?
Okay, well, if we go back to a conifer stand to start off with, because of the higher stocking and it's a lot easier, often it's easier to get regeneration in a conifer stand on a fairly low fertility site. The control that you gain of the seed bed is often by the regeneration itself. Now in broadleaves, you're aiming for a lower stocking, and the regeneration tends to be a bit more difficult to get of trees. So in southern England, because of our history, and it's a very specific history, this history is not, you don't get these stands dominated, or sorry, with an extensive hazel understory. In France, for example, this is a legacy of the previous management system. And hazel is very good, but of course, one problem with hazel is you can't recruit it into the main stand. Now, excuse me. You can with birch, although birch is not wildly valuable, but you can, and I do. In France, for example, the equivalent understory species include things like lime, hornbeam, and these are, and sycamore, and I use sycamore a lot. Sycamore is also a very important species that can be both an understory species and can be recruited. The thing about hazel understory is that, yes, you're right, you don't want too much. You don't want it to be partly because you have to cut the understory more or less when you thin the overstory. Now, currently, there's not really a market for that quality of hazel. Generally, occasionally there is, but not generally. So that has to be done at cost. And obviously, the more hazel you've got, the more costly it is. The less hazel you've got, the more chances you lose control completely and your sward turns to grass, which is the worst thing that can happen. Bramble is much better than grass. The other thing to bear in mind is we now have access to much cheaper small-scale mulchers, which I've got operators that I train, now trained, so I can do very focused mulching as well. So this enables me to have more direct control over particularly sort of brambly areas. But if you've got hazel understory, the worst thing you can do with moderate deer populations is to cut the understory and don't thin the overstory, because that will lead to a reduction in your understory. Once you've lost the understory, it's quite difficult and expensive to get it back.
Okay, thank you. I should say to people who ask questions, feel free to type in an addendum if you feel that we haven't addressed the question properly. And a question back on the selection of high quality stems, and the question was to how this linked to risks of squirrel damage. And I was also going to add a supplement as to, did you have to permanently mark these to facilitate the harvesting?
Okay, well, the presence of squirrels is a significant issue. What it effectively means is that, I mean, without going into all the fun and games about how we control them, generally I have reasonable control, but not ideal control. And quite often you have scenarios where you've got good control for 6 or 7 years and then no control for 1, which in species like oak can be very damaging. So one thing is that when you're talking about converting younger stands to irregular, you are not faced with a regular distribution of good trees, partly because some of the trees have been damaged by squirrels. So squirrels mean that you have to, again, you have to adapt to the fact that the best trees are in an irregular distribution. And obviously, once the trees are above a certain size, the squirrels are not so important. But you're absolutely right. And of course, if you have no control, then you end up with no trees that are capable of being recruited up into the main story with anything apart from a firewood value. The question of marking trees, the only time we would mark trees is when you get to the stage of development where you've got a mixture of big trees, and we haven't talked about permanent extraction racks, but that's what we use. We use a network of permanent racks every 30 meters. And as the regeneration, and it can sometimes be supplemented with planting, begins to develop in this matrix, an open matrix, you may well find that you've got a situation where you have a particular tree that happens to be in the right place in the structure. They're called sprinters in France. All the regen is talked about as being in the waiting room. And what you're trying to do is get one pole in the right place in the structure. And if you do, that's why it's called a sprinter. It grows very quickly up into the upper story. So in that scenario, you've got perhaps 10 trees a hectare, perhaps, or an acre, which are really important for the development of the stand. So in that case, when we're marking the overstory, if we come across a small tree in the matrix, which is really important, I'll put a blue mark around it. You can't have too many. And a combination of that plus the permanent racks mean that you can fell big trees. We don't care about, they're trained not to worry too much about dropping things on regeneration that doesn't matter. But with broadleaves, these trees are so important that we do put a blue mark around. But it's a quick thing we do as we go through and mark the main stand.
Okay, thanks. There's a kind of supplementary to this, touching on your extraction racks. When you're starting to transform management to an irregular approach, does the investment in the extraction racks affect the initial profitability of the operations?
When I'm talking about extraction racks, I don't mean metal tracks. All I mean is alleys. They're permanent gaps in the forest and we try and concentrate the forwarding operations on those as far as we can in order to reduce impact. But it's to create a framework. It's really important to create. It creates a framework in which you can do the felling, and if you need to do enrichment planting, that's where we do the planting. We certainly do not go planting in racks. We do never do that. So we set up the structure of racks first. But it's not a cost. It's only a cost in the sense that we might have to remove a nice tree in the rack because it's where it is. That's the only time I'll ever fell a tree where it is. Even then, we try and maneuver around so we don't fell a medium-sized, good quality tree to form a rack. So there's no cost involved in that. And generally, obviously, as you go further into the system with bigger trees, then your harvesting system changes. That's a big subject. Come on my course and I can talk to you about that.
Well, someone has touched on this, Ian Froggatt. How can we minimize collateral damage when it comes to felling large broadleaf trees within an irregular structure?
Well, that's exactly what I've said. And we can show you very good examples. Stour Head, which has got 55-meter Douglas fir, 16.5 cubic meters per tree, 2,500 quid each, which are felled in a matrix, and a year afterward you don't know, you can't see the effect of it at all. So it's all about setting up this network of permanent racks and also being aware that there are key elements in the structure that you need to avoid, but obviously not marking too many of those because the fallers cannot do, they can only do a certain amount. But we've found it's no real problem. You need skillful harvesting guys who have some experience of the system and buy into it. But we've got very good examples that can happen without too much of a problem. Again, you've got to remember that these broadleaf stands are at relatively low growing stocks, so they're fairly open structures, and so it's not that difficult to fell the trees in a way which avoids damaging the key younger elements of the. And again, they're often just a few really nice poles that you're trying to avoid.
Related to this is a question, does your experience with selective harvesting give you any concerns about an increase in branchiness in as a
Right. Well, I'm not so much from that. I mean, normally, again, there's another quite big issue. When I was trained, I was trained that oak trees were always pretty awful form, and you needed 10,000 in order to get 5 good, 100 good ones, and all of this. And this, when I started doing this in broadleaves, it did concern me a bit. I thought, well, you don't end up with that many in these structures, and they're sporadically distributed around. And I was thinking, well, surely that you need loads in order to pick the unusual one that's got good form. But it turns out that's not actually how it is. And when I started to go to France and look at much more developed irregular broadleaf stands and talk to the foresters there, they said, well, no, it's not like that, because the bad form that we often see in plantations and in plantations on open sites or following clear fells is because, particularly oak, but it happens with ash as well, the direct overhead light creates a situation where in general the form is poorer. And if you have these trees arising in stands which have more diffuse light in them, then they don't want to be growing underneath a crown. But if they are next door to a larger tree in these open structures, they said that the form is often better. And they showed me a number of situations where this was the case. And I was actually in one of there aren't that many developed broadleaf stands like this in the UK. I've got a few, and there's one very good one at Cranbourne where the CCFG meeting is going to be visiting next spring. And that's a very good example. I was looking yesterday at this existing exact point, and I think we can demonstrate that in diffuse light scenarios, as long as the trees can see the light above them, you generally do get better form. You still have to have more than you want in France because of the squirrels. The French foresters actually just like individual trees because it means they don't have to do any tending. But we couldn't do that in England because of the problem of squirrels.
Okay, thanks. I've got a question which quotes Oliver Rackham and his proposition that the arrival of oak mildew affected the ability of oak to regenerate under a canopy. Is that something that you see as a concern in the stands you manage?
No, I'm not aware that in the basically oak mildew is not an issue in these more open stands with good airflow. And we're not talking about oak growing underneath other things. We're talking about places in a more open stand where there is direct sunlight above, but where most of the light that's affecting the tree is from the side and is filtered through the leaves of the upper canopy. So, I mean, I think this is a deep question about. I was told repeatedly when I was trained that I don't know whether articles written that you cannot regenerate oak in an oak stand, which is completely. Well, how come we ended up with all these oak stands before the foresters appeared in the middle of the 19th century? So, but it is to do with structure, and for whatever reason, the structures which have been developed in eastern France that allow this process to happen, we failed to be able to produce in England for a long time, or we didn't try to. Now, clearly, the other big issue is deer. And I mean, that's by far the larger constraint in terms of developing this process. And they are the things that are going to affect you. Now, the other thing I will say is that certainly in the last 10 years, when we've been diversifying these stands and we want oak, then we have done enrichment planting as an insurance. Because I still, to be honest, have not achieved the oak regeneration that they've managed to achieve in eastern France. The only place I've seen it that it does work quite well without really trying is the wire forest, which has surprisingly similar ground conditions to northern France, where uniform shelterwood is practiced. You've got to remember that most stands in southern England are relatively fertile. And so it's not easy to get oak regeneration, but it's possible. And if you plant it, then there's no problem in including it within the irregular structure.
Okay. You touched on this PhD on ash dieback, and in our preliminary discussion, we talked about the links between irregular structure and ash dieback. Do you want to say a bit more about that?
Yeah, okay. What I might do is I'll just bring up a slide if I can work out how to, here we go. If I can make that work. There we go. Okay, so again on the Rushmore estate, this is 1,000 hectare SSI, 60% of the stands dominated by ash. We've been using ash for about 50 years as a way of regenerating the stands, and this very slow movement from predominantly hazel and birch over 200 years into forms of high forest had largely been achieved through ash. So when ash dieback started to appear on the horizon, there was obviously a significant threat. So I happened to come across the first report that was done by, there was a big project funded by DEFRA, and there was a report on the genetic aspects of ash dieback. And I didn't understand most of it. I just understood the bit at the end, which was a summary bit. And it put me in touch with a guy in John Innes Institute in East Anglia. And he talked to me about the work that Andrea Harper had done from York. So she's the one that identified the genetic markers. It's in RNA, not in DNA. So RNA, the thing that turns the genes on. That makes it actually much more difficult to collect the samples, but it's in RNA, and it's quite complicated. I don't really understand it. It is, though, it's a continuous variable. So it happened that when she achieved this result, they happened to be aware of a provenance trial at Little Wittenham in Oxfordshire, where they brought together about, well, what number of dots on the screen, individual ash trees from all over the UK, looking just at their growth. They weren't that old, so they're all quite young, and they were coming to be overwhelmed by ash dieback. So they decided they would take they would look at the genetic markers on these trees, and then look at the observed damage, and they drew this diagram. And so up the bottom is what they predicted the damage would be when they looked at the genetic marker. And then up the left-hand side, they had the observed damage. Now, most of the publicity that's arisen out of this experiment has been directed by the little green box on the left. Because at the end of very low, where the predicted damage, i.e. the genetic marker showed very strong tolerance, there was a very strong relationship with little damage. But directly you move away from the first 4 or 5 trees, you can see the data's all over the place. So I said, now that led to the idea that what we need to find is one of those trees right at the bottom end there, and they called it Betty, and they said, we're going to find this tree, and then we're going to produce all these other trees and plant everything up, which always seemed to me to be highly unlikely. So when I saw this, I said, well, there's obviously something else going on, isn't there? And they said, oh yeah. And I said, well, you do know that we can control the individual vitality of ash trees by stand management. And they said, oh, really? I said, yes. And so we surmised that one of the major reasons why the data goes everywhere after the first 5 is that there's a significant influence in whether the individual trees had high vitality or not. And we also surmised that those trees, I don't know if I can show you, but these trees here, oops, sorry, that's not going to work. Sorry. I don't know if this is going to work. There, these moderately tolerant trees, particularly if they're in stands which were had more beneficial characteristics, there was a larger proportion of moderately tolerant trees that would survive the disease if they were in good condition. And this is where the project then came from. So what we've done is we've taken 150 trees across a range of stands within Rushmore, varying from different stand structures, some closed, some not. These stands have a history of thinning, which is very unusual, really. But the general results, and the results will be written up early next year. I will read the results. So the results are, firstly, that there is very significant genetic variation between individuals. The first gene sequencing shows some individual trees with some of the highest tolerance that's been found anywhere in Europe. At the other end, there are trees where the gene is completely switched off, which tends to be associated with vitality. Where you have a combination of moderate tolerance to ADB plus high vitality, i.e. large crowns, these have lower degrees of damage. Stands with high levels of spore production are always likely to have higher degrees of damage. So if you've got high density of ash, i.e. not any other species, or if you've got just high densities of trees because the stands are closed, this inhibits airflow and it promotes increased humidity and spore production. Another fundamental thing is that trees below about 20 centimeters, we're not sure about this limit, are inherently more likely to suffer. So you get this, as I referred to in the presentation, the worst scenario are these dense pole stage stands of pure ash, where even though you will have a proportion of the trees that are moderately susceptible, because they are close together, they're under stress, they've got poor crowns, and they're fundamentally more susceptible because they're small, even the moderately tolerant ones die. But if you have a scenario where middle-sized trees are given big crowns, they're grown in relatively low growing stocks with good airflow, and ideally with a mixture of other things as well, then we anticipate that we get better survival. So at Rushmore, I think we're going to end up overall with probably about 40 to 50% of the trees surviving across the estate. And what it comes down to is that if we end up with the sort of irregular structures that I was talking about before, there's this sort of playing field between about 14, 15 and 21 with ash. If we had stands which perhaps were no more than 50% ash at that sort of stocking, and that you could, and you do selective harvesting, because of course the key thing is we want to remove by thinning the trees that are demonstrating their low tolerance. So if we keep selectively harvesting and go for the trees that are showing the most effect, we will end up with stands with higher proportions of trees with moderate tolerance, and in the long run the regeneration will then be more tolerant. And I think we can demonstrate at Rushmore that that's the case, and hopefully when all the science comes out, I think we'll find that's underpinned by the scientific results.
Great. Thanks very much, Andy. Can you stop sharing the screen for a second?
Sorry, I will, yeah.
Yeah. We're on the last legs. For the benefit of the audience, Andy kindly agreed to hang on, depending on questions, till 1:15. There's a couple that have come in which kind of feed off each other, and I'm going to take together. One was the extent to which you were able to fit your irregular silviculture within the context of management grants and higher tier payments. Mm-hmm. And following on from that, if you were trying to sell CCF, a CCF approach to an owner, what would be the key points that you'd be wanting to get across?
Let's take the second one first. I think the key one is lower risk, higher resilience, the ability to control your costs, and also, this is particularly in the lowland scenario, with relatively limited forest resources in a particular estate, you know, the 1,000 to 2,500 acre scenarios. We've got to try and produce a quality product from part of the forest rather than just trying to produce cellulose. So, I mean, all the estates I took over were in significant deficit, and we've turned them all around and we now make a profit. Now, the whole question of whether irregular is more profitable than evenage is a big complex subject, and it's bedeviled by the fact we have very little data. But in practice, in the lowlands, there hasn't really been an alternative that's worked. People have tried to do plantation silviculture in broadleaves and in conifers actually, and the high cost of restocking has meant that it very rarely goes beyond a couple of rotations in the private sector. Coppicing really doesn't work on any scale. So it's not really as if I've had much to compete with, really. The history of a lot of these estates has been pretty poor, and the economic performance has generally been terrible. So the people who are reasonably broad-minded and want to have a go, we've managed to produce some very good results. In terms of the grants, well, despite the government policy, which appears to be promoting CCF, it's taken an awful long time for that to actually filter down to the incentives on the ground. And like all incentives, you know, in the end, the people who design them, they're not the same people who actually have much experience of managing the forest. Saying that, the managers like me have very little experience of designing a grant scheme. And very recently, things have started to change a little bit with regard to there being a more automatic response to allowing grant-aided work that is based on moving towards irregular structures. It is, in the last 3 or 4 years, it is beginning. So I'm a bit more hopeful. Of course, in Ireland, they've introduced a specific grant for CCF, and that was something which the Forestry Commission asked me about 15 years ago, and we did have quite a long discussion, but in the end, they thought it was too complicated to implement. Ironically, the idea of a higher management grant, which is what I came up with based on various thresholds of measurement determining how far away from the norm you went, is quite similar to what's been introduced in the CS higher tier. So I'm reasonably hopeful now. I'm reasonably hopeful.
Okay. There's been one additional, there's been a comment from Graham Gill that in his experience in the north of England, he's not seeing the tolerance to ash dieback that you've described from the south. I don't know whether you want to.
Well, I mean, you're right. A lot of stands, I mean, I don't know quite how to say this, but a lot of stands are neglected and badly managed, I will say it. And if you have dense stands of underthinned ash, and particularly if they're small, you're going to be in a difficult situation. I should also say that there's a difference between ash that are growing on what you might call ideal sites, which I generally have, where you've got less ideal sites, for example, heavy clays, the damage tends to be a bit higher. So I am talking about stands that are in a particularly favorable condition to start off with, I suppose. But I think it's worth saying that in whatever, however large that area turns out to be, I think it's important to just note that there is a direct relationship between management and structure in those circumstances. How widely it can be applied, I will accept, but that depends a lot on past management.
Getting towards the end, and I'm aware that you had a cold. And
no, I'm all right now. I'm on a roll.
Okay. I won't keep you too much longer. There've been a couple of questions that have come in, which are carbon related.
Yep.
And I was going to ask, in your experience, do your owners or people who you discuss CCF with feel or see benefits to irregular forestry in terms of increased carbon sequestration or more stable carbon accumulation? Is this an issue that crops up in discussion?
It's beginning to. there are two very distinct scenarios. There's the scenario which is regarding afforestation, and which I have been involved with some significant afforestations, actually largely coniferous in the last 5 years on farmland in the south. In terms of existing woodland, it's beginning to be talked about, although there's quite a lot of confusion about the methodology, and there's great confusion about what is truly additional carbon sequestration within an existing woodland. At the basic principle level, it's been demonstrated, and there's quite a lot of work done, again, by the Max Bruch-Hemerschi has done a lot of work. In principle, stands moving towards an irregular structure without lots of clear felling are in principle likely to have a better emissions stroke sequestration trajectory. There's less emissions from clear fell. And again, we're not really very clear yet about what the emissions are in clear fells. But the other big thing is that if you have large trees within your production system, say up to 80, 90 centimeters, and it's absolutely economically viable and sensible to grow trees up to that size if your price size curve works, and if they're growing isolated in the top of the structure. So in that situation, I can show, and we've had more time, we can show that over the whole system, so let's take a 55 years of irregular management, say a Douglas dominated stand with other species, and compare it with a 55-year clear fell of a traditional conventional system, it's clear that we're producing significantly more big trees and less small trees. And it's significant if you go up to 90 centimeters. And what that means is that effectively you're producing a significantly higher amount of logs. And the logs go into building, or if it's a broadleaf stand, into furniture. So there is a significant carbon benefit in terms of the forest products that are being used. Now, in terms of actually an afforestation, you find that actually, because you're trying to transition your forest from when it's planted to one when it's 60, 70 years old, that's actually got quite a low growing stock. If you're only being paid credits for the trees that stay in the forest, as with the current Woodland Carbon Code, then that approach will generate less credits. If directly you introduce the idea of forest product sequestration, which will come, then the benefits of CCF from an afforestation point of view will be clear. So the difference is, in terms of the world, if we all, and what one very interesting, sorry, I will just say this, last week, there was a rather strange article in the Times, I think it was, about this Swedish farmer who was pictured in front of a load of logs, who just discovered continuous cover forestry, apparently, although, of course, in Sweden and Finland, it's not popular at all. But the background to that story was very interesting. The European community, they follow a process which basically is looking at the cost effectiveness of reducing carbon emissions. And there's a particular, I don't know the detail, but there's a particular parameter they use to evaluate it. And following quite a lot of work they've done, they've decided that it would be much more efficient. Well, so there's a balance between the two, but there would be, you get much better bang for your buck if you change the management of existing forests than if you rely solely on afforestation. Now, this is a very fundamental point in the European Union, because then this has allowed the European Commission to start introducing policies which make the forest industry take account of the emissions of clear felling. And this is extremely unpopular with Finland, particularly, who only joined the European Union on the basis that there would be no common forestry policy. The whole question of developing carbon credits based on change of management is a big complex problem in the West. It exists in part of the world, but it's very, very expensive to actually set up and monitor. And if you'd asked me this question 3 or 4 weeks ago, I'd have said there's very little chance of it happening in the West. It does happen in California and Indonesia. But this change in policy from the European Union may change things. The problem is, if we've the people who've already changed management, of course, there's no additionality. So it's only in scenarios where you've been either, where you can say you've been working conventionally and you're changing, that you will get a credit. But we are doing, I'm involved with a project in Ireland next year which involves stand modeling and carbon modeling. And actually they are going to create a dummy standard, which looks at this product sequestration element, and also the whole question of change of management. And this is for an organization, which is an investment company or investment house, which has been buying up even aged conifer plantations in Ireland with an explicit objective of turning them into irregular. And they're looking at the carbon. So within a year or so, I think we will have more concrete data on that whole aspect.
Okay. Thank you, Andy. There's one or two more comments come in, but I think we've got to just past it. And I think you've given us a really good talk, a good amount of your time. You've managed to wrap a lot of 30 years experience into 35 minutes of talk, and that was really impressive. Just a brief plug, you touched on Finland and Sweden a few minutes ago. As it happens, our next webinar, we're going outside Britain for the first time to a colleague in Finland, where CCF has been reintroduced or introduced into the management of boreal pine forests. And that'll be quite a different talk, I think, in some respects from what we heard today, but also interesting to hear the thinking. So Andy, on behalf of the group, thank you very much for your presentation today, taking the time. Thanks again.
You're welcome. Well, thank you, Bill.